We are now commencing with our session on grey water management. This session shall attempt to explore the various technological options and models at community level and household level interventions. It shall also explore potential revenue models and incentive for entrepreneurship. And we have a distinguished list of panelists for this session, and I would request all of them to please take the dais. We have Shri Harshvardhan ji from CDD Society, Shri Shrikant Navrekar ji from Nirmal Nirman Kendra. We have Shri Abhijit Banerji from Finnish Society. Sir, are you here? Okay. And our fourth and final panelist is Shri Ankur Sadana from HCL Foundation. Sir, can I please have you on stage? Thank you. So I'll quickly introduce all our panelists, beginning with Shri Harshvardhan. He is CEO CDD Society. And Shri Harshvardhan has close to 2 decades of experience, and he has always been committed to the cause of inclusive growth and prosperity of rural India, right from starting his journey with Gujarat Cooperative Milk Marketing Federation, better known as Amul. And with CDD, he continues this vision in bringing integrated, nature based, inclusive water and sanitation solutions to improve quality of life of communities. We have with us Shri Abhijit Banerji, Director Financial Inclusion, Improve Sanitation and Health, also known as Finnish Society. Under his leadership, Finnish Society has worked extensively in the area of waste management in 12 states across the country and has given effective and replicable models for waste management, including waste treatment, some of which we hope to see today. Then we have with us Shri Shrikant Navrekar from Nirmal Nirman Kendra. Shri Navrekar has close to 4 decades of experience in the field of environmental sanitation. His areas of expertise are rural sanitation, toilet technology, solid and liquid waste management, and he has worked with leading development agencies such as the World Bank, UNICEF, WaterAid India, IIHS, and Knowledge Lake. And finally, we have with us Shri Ankur Sadana, Senior Lead from HCL Foundation. At HCL Foundation, he leads a team of development professionals, and through which HCL is doing optimal interventions across agriculture, education, health, infrastructure, livelihood, and water and sanitation in several villages. Before we begin the session, I would like to state that our panelist Sri Harshvardhan might have to catch a flight and he might be leaving us. But we'll start with his presentation first and foremost. And if the audience has any questions for Sir, we will take it right away instead of waiting till the end of the session. So, requesting Harshvardhan Sir to kindly proceed. Good afternoon. So as we wait for presentation to load up, I will take this opportunity to introduce CDD Society. So CDD is a NGO which is the consortium of around 22 NGOs from different parts of India. And we are basically engineering-led NGO. So we have got more than 50 engineers from reputed institutions of India, and who all have one fundamental belief that nature is the best engineer. And we also believe that most of the modern problems we are facing is because of the rupturing of the bonds between the nature and the humans. So this is about CDD Society. And now can we move to next please? So we have this drinking water, and the next session is on the black water, and we have got then grey water. But black water is never black. How many have seen the black water is black? But then why we call it a black water? And grey water is never always grey. It is turbid, it may be yellowish, it may be translucent, it may be like white yellow, anything. Sometimes grey too, but we call it grey. So the whole point of liquid waste management is that we have to take care of two things, which are contaminants and pathogens. So pathogens create health hazards and contaminants create environmental hazard. Can we next please?
Do we have one? So drinking water, if we see from the pollution angle, drinking water has got biological oxygen demand of 2. These are the CPCB standards. And black water has biological oxygen demand of minimum 10,000, which goes up to 50,000. And in between, whatever is there, it is called grey water. So in that sense, grey water has got a huge range, a very huge range. And the problem stems are just different. So just to give a very gross analogy, somebody has got a cough, somebody might have a viral fever with cough, and somebody might have TB. You would not give same paracetamol to all of them. So different pathogens and different contaminants require different treatments. And that is one thing which has to underlie every intervention. So this is a rural Indian context. Whatever we say grey and black are separate, they are not. Most of the places, the septic tank overflows goes into storm drain. Most of the places, sometimes even the fecal gets directly disposed into water and storm drains. About 72% of children fecal sludge material is disposed into environment, and this intermixing of black and gray water is a common phenomenon, and hence you will have pathogens and contaminants even in gray water in India. Only the strength will differ depending upon the dilution effect, how much water is there available in the system in the village, which is flowing through the storm drain. Otherwise, the concentrations are there. So to feel that our grey water is purely only grey is not true. And also, grey water has got also evolving many parts of constituents of grey water. We say grey water are considered black water in other countries, like kitchen waste. We consider it grey water, but because of its high concentration of contaminants, it is considered as black water in many countries. So the solution has to be seen accordingly. Now these are some of the data points. How the drainage and disease burden is increasing because of waste poor water management in the rural India. You can all have a look, and these are nothing to this. Figures are self-explanatory. Now this is what is happening. So many places we are going with the complex technology in rural areas, which are simply not working. So this is a modern conventional system which has been set up from 5 kilometers from our office in Bangalore, and within 6 months it stopped functioning. Now there is algal growth. So it itself, the treatment system has become bimar or sick. It itself needs some treatment. So these complex solutions need not be operated in rural areas. If we do, the seeds of solutes are so given in the fifth day, first day one. So this is what I was saying. So grey water has got different constituents. You have got light grey water and dark grey water. If you include kitchen waste, it is the concentration of waste will increase. You need to have different treatment system for that. And why that is important? Because a very high public risk, health risk, and I will come to that. So these are some of the figures. These figures are slightly dated. About 5 years ago, the per capita generation was about 55 liters, 48 liters in India. The figure will go up as JGM comes into being because the water consumption, water availability will increase in the villages. So these are some of the characteristics of black grey water, and you can see that kitchen and laundry water, the COD and BOD, which are the two key constants for defining grey water concentration, are as good or as high as black water. So if you, and others it is lesser, but the contaminants become high if you add kitchen and laundry water in the grey water. These are some again the pathogens also. The pathogens are also present because whenever there is human urine or human waste or something there out there, there will be some pathogen which will get mixed into grey water. So this is what is happening. You have got, there is no, I will again reiterate the point, there is no single grey water source in India. Most of them will have some level of contaminants. And some of the characteristics you have seen in rural areas of Karnataka, where it has gone from 50 to 100. Again, wherever dilution is high, because of higher water availability, the concentration is lesser. But wherever the concentration or availability is low of water, fresh water, the concentration is high. So again, the loads of grey water and black water, the contaminants load will depend upon lifestyle or what is going into that system, what is the relative weight of kitchen waste or what is ready waste of wastewater is going into the system. So again, that's the single point is that, or main point of which I'm trying to emphasize, there is not a single fixed formula because you have got a very wide range of problem which will depend upon a various factors what is going to define your grey water. Hence, you need to test grey water or water strength before providing any solution. So this is soak pits are one of the most decentralized common systems which are available there, but they would not work in the high water table area. And one more point is there that the soak pits do not allow for any nitrogen decomposition or nitrogen cycles to get completed. Once it is in the soak pit, nitrification and denitrification, which are two very essential elements of nitrogen cycle, do not happen. And it has got a very huge public health risk because if nitrogen does not break down properly, it creates nitrosamines, which is the carcinogenic element, and there is a very high correlation between high nitrogen in water and thyroid cancer and gastrics. For your information, US FDA does not allow any nitrosamine in any medical products to be generated in the sterilization process. And the rules that it has to be 5 meters, 6 meters, 8 meters. This the water source and soak pits. This was on a study which was done in 1950s in India, and that study was based on certain assumption that it had to be sandy soil, the slope had to be certain type, and then it was felt that the safe distance of soak pit and water source could be 4.5 with a margin of error it was taken to 6 meters. But whenever these assumptions do not hold, when the soil is coarse, when the water table is high, whenever the problem of slope is there, or because any reason, if in geology you have got rock surface, there are fractures, these assumptions will not work. So soak pits will not work everywhere. You need to be careful of the assumptions which are underlying this principle. Since many a time we are not aware that under what assumptions these soak pits were promoted or they were, recommended, we end up making mistakes. Now, this is what I was saying about nitrogen challenge. That unless and grey water essentially has got human urine, where 80% of whatever nitro discharge from human body occurs, it occurs in the form of urine, not excreta. So if you have got urine in your grey water system, it is going to create a nitrogen problem which needs to be fixed. Otherwise, we are for a problematic state. And again, nature comes to the rescue here. If you use or try to use conventional systems for nitrogen removal, it requires huge amount of air. And the nitrogen does not get removed from the water unless you have got your carbon removed. So to remove and for removing nitrogen, there are two processes. Nitrogen, which requires excessive oxygen, and then denitrification, where oxygen deprived environment is required. So it requires two contradictory chemical stages, which if you want to do in a conventional system will require a huge investment. The best option of creating nitrogen in nature remains application on soil, because if the net it is exposed to the air while going to the soil or when getting discharged, nitrogen will nitrification will happen. When it is seeping into the ground, their exogenic environment will get converted and the natural bacteria will complete the process of denitrification. In rural areas, these nitrogen rich elements should be applied on the ground because A, they will reduce your fertilizer consumption and associated green gas emission. And second time, they are the most cost effective methods of dealing with nitrogen. So these are few factors while dealing with grey water management. We need to take care of strength of grey water, space availability, soil type because of permeability. If there is a black cotton soil, the water will not get percolated and it will flow back in the system. So these are three high water table because the water table has the contaminants and pathogens will get into your water stream and then they can transport it to any length. Like I was saying in 4.5 meter or 6 meter, these are for wherever there is a soil layer. If the water layer gets into in between, then the contaminants and pathogens can be carried over to any distance and then it may create a health crisis. So generally, we should have a system where we can have carbon removal and then some wetland where some nitrogen fixation takes place through root zone of the plants. So these are some of the cost-effective ways at which, when at decentralized level, at a household level, at a cluster of levels, household, it can be done. If you have got larger spaces or a community center, then weight stabilization pond, community subpits or dewards are necessary. If you want to go for waste stabilization pond and the strength is higher, please put up aeration unit. And you will have to figure out how to the maintenance of that. Otherwise, the system will not function. After a few months of operation, it will start stinking and it will another create order problem. So again, depending upon the strength, if it is less than 50, please go for community soak pits or any soak pit systems because it will not contaminate the environment or groundwater aquifers. But if it is of higher concentration than 50, please go for a higher order solution which takes care of the organic part. And if you have a reuse policy, so before designing any treatment system, have a policy of reuse of grey water because this water is in scarcity and this nutrient rich water can be safely used in agriculture. So why not use it in agriculture, then waste energy for even because huge amount of energy will be required, and then two very contradictory environments of oxygen rich and oxygen poor will be simultaneously required to treat oxygen. So this is a waste stabilization pond. It has got three features. It is available in Google or anywhere. You can just see there are three stages: anaerobic, aerobic, and maturation pond. But again, if the strength of wastewater is high, the problems will be there for its operation. Then DWAT is a system which has been pioneered by CDD. Again, it is nature-based and plants and operation. Only civil construction has to take care, and the system can work. And then you have what free surface wetland. But again, mind here, it will not work on higher concentration. For less than 50 only, we should apply these solutions, BOD. And pathrite is again a newly promoted solutions. It also moves up and down. This is, I would say, motion-based movement of constructed wetland where you need to have higher maintenance, but it also functions. So at a household level, whenever you are doing a system, please have a system for grease removal because the fat will be a component which will get into the wastewater from the household kitchen. And if you do not take care of waste, again it will percolate your soapet systems and then it will create a film and the water percolation will decrease and the system efficiency will get reduced. And then you can have soak pit or wetland depending upon what the concentration of the wastewater, the nature of wastewater is. So these are some of the systems which again depending on the strength at decentralized level, household level, at community level, at cluster level, it can be easily designed. So we have 2 more minutes to the thing. Yeah. Thank you. And of course, if any questions are there. So you have a question? Thanks, and I will take your leave. I'm sorry, but I have a flight and I would like to leave. Thank you. Now requesting Shri Abhijit Banerji to kindly share his work with us.
Thank you. And good afternoon, friends. And thanks, ISC, for inviting Finnish to share their work, their views on Greywater. Not very technology savvy. So, there it goes. So, this is a matter of great interest and also personal concern for me because as you can see, 2000 study put an estimated 18,000 million liters of grey water being generated. And a recent article I was reading by in Down to Earth, they estimated at 31 million, was it? Yeah, 31 billion liters of water daily. This is a 23rd of August article that they had come. And it's in that article again, they say that if 50% of that were to be treated, then it can reduce water scarcity. So that's the kind of opportunity which we have in front of us. And because you see, on the other side, the kind of hotspots that are there, right? And groundwater is getting majorly depleted all across. And this is a concern which can be addressed. It's also an opportunity for all of us to be able, if we were to address the issue of grey water treatment. Now, this is, of course, this slide I put up because, often I am asked why finish, when what is finish, and what is it that you guys are out to finish. So yes, we have the BHAG of trying to address the sanitation system, the challenges in the country. We began actually as a program supported by the government of Netherlands, and the idea has been that can we address the sanitation challenge in the country using microcredit. So it began in the year 2009, and because the model itself was a success, it has today gone to 5 other countries, and we are now looking to expand the number of countries further. 4 countries in Africa and our neighboring Bangladesh, plus India, of course. Besides sanitation, we also work on solid waste, liquid waste, which is the topic that has been given to me here, fecal sludge, wash in schools, and of course, we do some research on these areas. So our initiatives in wastewater is related to, water. We of course realize that it is directly linked with civilizations. When you look at civilizations, we typically find that all civilizations have typically began along the river basin. So when they talk about Nile, when they talk about the Gangetic Basin, so that's where, the importance of water actually is. And we, as an organization, we do not have any technology, so we are technology agnostic. We look at solutions which are most appropriate, and how we go about it is we look at look at it from an end-to-end perspective, and with the idea that the solution has to be most appropriate and low maintenance. We do capacity building related to that, designing appropriate treatment systems, installing, operating, and maintaining the same. Of course, creating the ecosystem so that it can sustain, and of course, monitoring and before handing it over. This is our overall strategy. Couple of areas that I would just pick out from here would be the selection of appropriate solutions. So as Harshji earlier spoke about, when you talk about grey water, it has a vast gamut, right? It's quite a vista. And before we identify the solution, and we try and test it. In fact, we also learned it the hard way. We were given an assignment by an ULB down south in Punampatti, and we had completed the design for treating that particular drain. Having done that, and we did the mistake of not testing the input water. When we tested the input water, we realized that there was gray water. It also had black water. That is, septic tank flows were coming into it. So we had to change our entire design model. So it is from then that that particular point that you find, so, testing and selecting the appropriate solution came in. And the other point that I would look at is when we begin the program, we also look at the end. So, what happens to the water that is there? And how is it going to be used, and what kind of impact will it be there in terms of the net result? Because this evaluation is what makes a grey water treatment interesting, right? What is the kind of ROI that we are talking about? What is the money, if any amount of money that is invested, what returns will that particular ULB or the community get from it? And this is evaluated. It's not an easy task, and we also have not found, I will say, a very straightforward or a very clear answer to it, because in many parts of the country, water is still not monetized. So that is also a challenge. But how we have tried to do is by in through proxies, and when we see some of the examples that I intend sharing, maybe I'll be able to communicate that idea better. ये जो आप देख रहे हैं यहाँ पे, this is from a place in Chennai called Sembakam. So this is a design assignment that we got from the Nature Conservancy. This is a US-based environment consultancy firm. And the idea here is to treat 7 MLD of water and Greywater, Sembakam Lake में दो inlets में ये design बना था. And here also we initially thought that we will go ahead with only a reed bed, and but then given that we are talking about Chennai and the size of the reed bed was turning out to be pretty large, so we put in a semi-mechanized system, which means we added a aeration tank beside, of course, a sedimentation tank. The advantage being that the technology is relatively cheap, and of course, it has lower maintenance. This is the construction which is going on. The monitoring agency is IIT Madras. The expected cost of this unit is 2.8 crores, which is financed by the urban body. And we expect it to save about 70,000 rupees per day, because abhi kya hota hai Chennai mein that tanker loads of water is coming in. So this will result over a period of time. It will not happen, of course, from day one. It will take some time for that water to regenerate. So over a period of time, it will result in a saving of 70,000 rupees per day, which means about 2.5 CR in a year. We expect a payback of about 15 months. This is another plant that you can see. This is Sonaria in Dungarpur, a small ULB in Rajasthan. And here, the interesting thing is that you can see a pump there. Normally, these kind of constructed wetlands that we do it you'll see in the next slide. It is based on gravity. But here the challenge was that land was limited. So ये वाला जो part है, the one that is on the left hand side, that is on one side of the road, and the this side, luckily, you can see a line there. I'm lucky here. So the other part is on the other side of the road. So the pump is required to pump the water from the collection tank over there and onto the roughing filters. That's the purpose of the pump. It is basically to transport the water. So ये यहाँ पे क्या बोलते हैं डूंगरपुर में ये plant बना है, and it is functional as of now. This is the other treatment system that I was referring to. This is a usual constructed wetland that we do. So first part, you have the plant here, and then there is the aeration system that is there. And here, no pump is required because this is based on the gravity. We have got this type of a plant, one in Bangalore, which is a 14 KLD plant this is about 10 years old now, and it had cost then about 3 lakhs. The payback period that we calculated was 12 months. This is Gabe Sacker, and here again we had a twist. So, while we were told the ULB had said that this is again a treatment of grey water, but then when we did the testing, we found that it contained some industrial effluents. They were coming from a dairy plant over there. So, as a result of which, we had to change the design, and that's where you see an aeration tank. And from there, the sludge goes into the secondary settling tank. And the system that we have adopted is that the sludge which accumulates in the secondary settling tank, that partially is transferred back to the aeration tank so as to maintain the microbial load. And the clear water, of course, goes to the horizontal wetland. These are some of the more decentralized smaller units. This one is from NEC project in ashram in one of the ashram shala schools in Nasik. Evotranspiration method was used here, And since, like, I think Harshji referred to also the black cotton soil. So here also we had a similar challenge. And as a result, what was done is this: the pipe that you see over there, it has perforations, and there are grits in it, allowing the water to spread and evaporate. Plus, by using banana and some other hydrophilic plants which absorb a lot of water, so the water was managed. It's a very low cost solution. This is a community system for, the hand pump over there. So the water that is the wastewater that is there, it can be taken out and does not mess up the village. This is a 4 KLD small treatment system that was done at Srirampur GP in Nandurbar, again for the NEC project, treating household wastewater. There is a sedimentation tank, a rock filter, roughing filter, overall costing about 2.5 lakhs. Lighthouse Initiative, handful ITC is already here. ISC, of course, we are working with them at multiple locations, and wherein liquid waste, solid waste, all that is a part of the initiatives there. And IEC is another key component in the entire thing, because in our experience while working on Greywater, what we have noticed is that without behavior change, that is getting the community involved in the process, because while doing this Dungarpur plant, for example, it was bang in the city, and without getting the community on board, the initial days, the challenge that we were facing is the people would come and throw plastic bottles in the wetland, or they would but those filters, they would get choked, people will not keep it. So we had to organize the community over there, get the shopkeepers on board, so that there was somebody to look after the plants, because our presence is only limited. We are going to withdraw from that side. So behavior change is an integral part of the entire process. There's a picture from one of the ITC areas. This is again a community level soak pit, what my team calls a magic pit construction in Ranjangaon. Thank you.
Thank you, sir. Requesting Shri Navrekar ji to please share his work with us.
Is it coming? Yeah, good afternoon, all of you. Is it coming? Sure. Yeah. Yeah. The topic assigned to me for this presentation, or rather chosen by me, is a very narrow window, that is grey water management in household and cluster level. Before entering to the main topic of this presentation, a little background. All of us know that grey water management has been a major component of SBMG2, the second phase sanitation program. So my question to you all is grey water the only wastewater which needs to be managed in a GP? Or there are other wastewaters as well? Anyone? We will realize that grey water is only a part of liquid waste. Although it is important to manage the grey water, it has been emphasized in the program, but we must realize that while planning for a liquid waste management of a GP or a given village, we need to look into all these
wastewaters. Now again, technically there can be, we all know that black water, etc. But we also need to see the discharge point. That is, we generally give emphasis on household grey water. But in a village or in a GP, there are institutions as well, education institutions or other institutions, which also generate lot of wastewater, which can be black and gray. There is the yellow water, which I always call an orphaned waste. Nobody looks into it. That is also a major liquid waste of human origin, which needs to be tackled or which needs to be a part of our project. Then there are public water points, where a lot of wastewater gets generated. That also need to be a part of our program. And lastly, but not the least, is the commercial wastewater. Howsoever small or big that GP is, there are some commercial establishments like dhabas or hotels or laundries or slaughter houses where again some sort of wastewater gets generated. Now it is entirely different than the grey water, household grey water or household black water. But it has to be a part of our program. And therefore, my first slide was very important that when we plan for a Gram Panchayat or GP's wastewater plan, in addition to the grey water, we also need to look into all these types of wastewater. Now, of course, we will be emphasizing only on grey water in this presentation. What is happening today? Indiscriminate disposal not doesn't need to be taken into consideration. But people are doing something with this grey water. There are kitchen gardens, there are showcase pits, there are drains also. And unfortunately, drain is considered to be a technology for grey water, which is not. It is only a part of grey water treatment. So unlike ODF, that means in toilet program, we had to start from a scratch. They never existed toilets at all. But here people are doing something. Now, what does this mean to us? If we analyze these three, we'll find, although there are kitchen gardens, although there are soup pits, although there are drains, are they really scientific? The answer is no. Now, again, there are two repercussions. One is improvisation of existing structures can also help a lot. हमेशा क्या होता है कि जब हम नए प्रोग्राम की बात सोचते हैं तो चलो नए से सब कुछ करते हैं. No, it is not necessary always. So improvisation of existing structure should also be a form of our program, so that within the budgetary limits or within the limits of the people, we can improvise the scenario. Now, what could be the appropriate solutions at decentralized level? We all know that like solid waste management, there are also 3R in liquid waste management: reduce, reuse, and recharge. Now, reduce, there are no technologies, but judicious use of fresh water is very, very important, so that minimum quantity of grey water or minimum quantity of liquid waste is generated. अभी मैं खाने के वक्त जो गिलास रखे थे, मैंने सब उनसे पूछा, अरे भाई आपने इतना बड़ा ग्लास भर के क्यों रखा है? Just observe, people are taking a sip or two and keeping the glass again on the empty tray. How much water we wasted in this workshop itself? To reduce, this is very important. And it should be a part of our IC and BCC program. Then and then we can claim that yes, we are going in the right direction. Then comes second R, reuse. We all know the technologies like kitchen garden, community plantation, and agricultural pisciculture use. These are the technologies. And in case of recharge, complete leach pit and community leach pit. So this can be a technology options available at a glance. Now this is based on principles. But again, based on levels. The first level would be decentralized, that is household level management. And I would insist that we should first start with the decentralized level, whereby we can have kitchen gardens or pits. But it is observed that in a GP, if this decentralized technology is not possible, we immediately jump to the centralized one. चलो भाई ड्रेन बनाते हैं, स्टेबलाइजेशन पॉन्ड बनाएंगे या डिवॉर्स या और कुछ बनाएंगे. But we should keep in mind that in between these two, there exists one more level that is semi-centralized. What is this? Now, this again has a two subparts. One is management of greywater from group of houses where decentralized treatment is not possible collectively. And second is in a village, there exists some public water points like hand pumps, stand posts, etc. That also needs to be managed. This comes under semi-centralized or community level or cluster level management of greywater. So based on level, there can be three levels in a GP where we can manage the greywater. Again, there can be situations where a mix of these three also need to be considered. It is not that in a given GP only decentralized will work or centralized is necessary or semi-centralized. There can be a mix of all this technology that is also possible. Now again, before going to the technology part, some pre-arrangements are very, very essential. What are these pre-arrangements? Now look at this scenario. For example, this house, which has a place where everything is done. I mean, bathing also on the same platform. That is not a platform. It's an assigned place. कपड़े भी वहीं धोएंगे, बर्तन भी वहीं मांजेंगे. And if you, in your plan, include this house to be provided with some technology, may it be a soap pit, maybe a leach pit or whatever, or drain. Can you ensure that this water goes to that treatment unit? You cannot. That is why some improvisation is essential. Just have a washing or bathing platform. This pre-arrangement is also important, and that's why in our survey, this also needs to be covered whether that house has a structured bathroom or a structured place whereby we can ensure the flow of grey water into the treatment unit. So this is also very important. The next one, this also see the picture. This was the previous scenario, and now it is changed with a structural platform. Very simple and low cost intervention, but very effective. The second one is nanny trap. People always forget this. A very simple again, but very effective tool for avoidance of what? What is the role of this trap? You are hesitant to answer my questions. Let it be. This avoids entry of mosquitoes and exit of foul gases. So at every discharge point, if the house has multiple discharge points, at every discharge point, if it is a single one, at that point, you need to have a tool like this nanny trap. It was like a P-trap in the toilet. So this is also an essential pre-arrangement. And the third one is silt chamber. So this silt chamber is not required everywhere, but if you are going for a kitchen garden, if you are going for a community greywater management, and if you are going for a centralized system, silt chamber is a must. Now, in the second community greywater management and centralized systems, two levels of silt chambers are required, one at the household level and one at the treatment unit. So this is also a very important component of greywater management system as a pre-arrangement. Okay.
So we have 2 to 3 minutes for you.
Oh my God.
I'm so sorry, we're running almost 10 hours.
Just run through the slides. No problem. Sorry for my. Okay. Now, what are the technologies? At household level, there are three very simple technologies all of us know: kitchen garden, soakage speed, and dish speed. The beauty of this technology is they are based on local skills. It requires local material only. It's a low cost, low tech technologies, easy operation maintenance, and impact is very high. Now you know what kitchen garden is, but
I will just draw your attention that kitchen garden is possible in any terrain, may it be hard rock, high water table, anything, kitchen garden is possible. Again here, three things needs to be taken into consideration: availability of space, quantity of grey water, and choice of plantation. So each kitchen garden is a separate unit and needs to be planned accordingly. The second one is soakage pit. This is also a very simple and low tech technology for rural areas. You know the technology, I will not go into the details. Again, look at the pictures from the field. That is why hands-on training is very essential. Although the technology is very simple, there is a technology which needs to be done very scrupulous. The third one is leach pit. This is a brick-lined structure, just like a pit of a toilet, which also works very wonderfully. That means I call it a fit and forget technology. This works very well, and this can be a decentralized solution for the management of greywater. This is the case study. I will not go into that detail. The third one is magic pit. You all know many states are adopting this technology. This is also a combination of soak pit and leach pit, and it also works very good in a decentralized manner. Now, the second part is cluster level technologies. That means if it is not possible to deal with that individual household, for a group of houses, this can be done. For example, if these houses do not have enough space or adequate topography for this management of decentralized wastewater, you can take this to a centralized place and utilize in plantation, the gardens or roadside plantation, so that the entire wastewater from these houses can be utilized. Just like a like kitchen garden, this is a community garden. And if the space is the constraint, again, this can be replaced with a larger scalar leach pit. Now, this is the community leach pit, which can be used for the broader group of houses, and this works very well. Of course, again, I will insist that भाई इतने घर है तो बड़ा बना देंगे, ऐसे नहीं होगा. You have to calculate the volumes and accordingly you have to plan. Then and then only it will work. Otherwise, the scenario is like this. पैसा तो खर्चा हो गया, बेनिफिट नहीं मिला क्योंकि गलत तरीके से बना दिया. दिस इज ऑल्सो बना दिया, लेकिन पानी कितना आ रहा है, कितना पानी इसमें सोखना है, इसका हिसाब नहीं लगाया. ठीक है. Now there are other technologies as well, which I think some of them will be keywords: constructed wetland factory technology. These are generally recommended for centralized systems, but a smaller versions can also work for a cluster level technology management. Why decentralized? You know all. From point of generation to point of treatment, any waste, if we go on increasing the distance, these are the repercussions. Land requirement is high, capital cost is high, operational cost is high, and adverse impact on environment is also. That is why we should first opt for what could be the algorithm. Very simple. First try whether decentralized systems are okay. If that is not possible, go for semi-centralized. And if that is not possible, then and then only think for centralized ones. This is a very simple algorithm which you can follow. This is my last slide. How do we go? Generally, the trend is selection of technology and actual implementation. Nothing in between. इसमें सिर्फ होता है डीपीआर होता है, और डीपीआर भी एक्सटर्नल एजेंसी बनाती है और बना के देती है और इम्प्लीमेंटेशन शुरू होता है. No, if we want to have a sustainable grey water management or any waste management system, you have to follow this. Selection of Gram Panchayat, rapport building and demand generation. Many of us are doing this actually. Transact opt and TRA. This helps a lot. Then survey, waste mapping and resource mapping. That is also important. Fifth one is very important: plan of action involving community. हम इंजीनियर्स को बुलाते हैं, भाई क्या करना है? नो, let the community talk first, sit together, discuss, and evolve a plan of action. That may not be a very engineer plan, but that is important. Then DPR, then actual implementation and follow. This is very important. You must have heard this sentence. There is no rocket science in toilet. My anti question was, is there anything like toilet science? There is. So there is a science in soap pit, there is a science in fish pit, there is a science in everything. You have to follow that. That may not be a rocket science, but there is a science. You have to follow it. And therefore, this is my last slide. How do we go? Selection of right technology, very important. And the second one is strict adherence to technological standards. सोप पिट बनाएंगे, लेकिन कैसा बनाएंगे? As per the standards. Involvement of community from level 0. This is also important. Technical training prior to implementation. ODF का हमारा प्रोग्राम, हमारा अनुभव क्या बताता है? प्रोग्राम आगे चलता है, ट्रेनिंग बाद में होता है. नो, टेक्निकल ट्रेनिंग प्रायर टू इम्प्लीमेंटेशन, भले उसमें देरी हो लेकिन अच्छा होगा. Effective O&M should be a part of the entire DPR. And concurrent quality monitoring and hand holding support. हम मॉनिटरिंग कब करते हैं? पूरा प्रोग्राम होने के बाद, 1 साल के बाद मॉनिटरिंग बनाते, ये गलत हुआ, ये गलत हुआ, वो गलत. अब क्या करेंगे? सुधरेंगे नहीं. इसलिए कंकरेंट मॉनिटरिंग जब भी काम चल रहा है उसी वक्त क्वालिटी मॉनिटरिंग होना बहुत आवश्यक है. Then and then only we can have the desired results. So thank you and sorry for exceeding the time limit.
Thank you, sir. Finally, representing HCL Foundation here, Mr. Sadana, I request you to kindly share your work with us.
Thank you, everyone. And I assure I'm not taking too much time. So first of all, I would congratulate and appreciate the IC team to chosen this effective topic. Subject line is very important for everyone. So if I'm talking about HCL Foundation, so HCL Foundation is the CSR wing of HCL Technologies. So under the HCL Foundation, we are covering our reach is in 90 plus districts across country, including 20 states and 3 UTs. And as far as currently, if we are talking about in numbers, so we are impacting 5.5 million people directly or indirectly through other ways. This is the strategic framework program. HCL Foundation is trying to reach at every part of program which required with us to the sustainable development goal. In our rural programs, if we are seeing, so we are having the Samudaya program and the HCL Tech Grant program, which covers all the aspects in the rural area. And we are having the urban program, namely My Clean City and Uday, and we are having the environmental program called HCL Hari. And apart from that, to promote the sports and all other components, so we are having different special initiative like sports for change, power of one, my year, etc. So these are the thematic areas which we are covering under different kinds of program. If I'm talking about the specific point where I'm representing from HCL Samudaya, under the HCL Samudaya, we are covering all the thematic area, which includes water and sanitation, health, education, livelihood, agriculture, panchayati raj institution, and clean energy, etc. The whole objective of this HCL Samudaya initiative is actually we have the MOU with the cabinet of Uttar Pradesh, and we are developing a source code which is being a replicable model to across country, and some of the model HL Foundation Samudaya has already developed, which is being replicating in the other area of the states and in the districts of Uttar Pradesh as well. This is the topic which we are assigned. So my earlier friends already defined all the technical components, so I'm not this time going to the more technical components. So these are the like integrated waste management process. हम एक इंटीग्रेटेड वेस्ट मैनेजमेंट प्रोसेस पे काम करते हैं, जिसमें कि हम स्टार्टिंग करते हैं, क्योंकि अब इसकी रिक्वायरमेंट जल जीवन मिशन के आने के बाद से और बहुत बढ़ गई है। बिकॉज क्योंकि अभी तक क्या था कि गांव में हम देखते थे शैलो हैंडपंप और इंडिया मार्केट टू हैंडपंप का यूजेस था, तो वाटर का डिस्चार्ज भी कम होता था। अभी जल जीवन मिशन हर घर जल की योजना आने से लोगों को हर घर जल टैप वाटर सप्लाई मिल रहा है, और इवन HCL ने भी इस तरह की 30 वाटर सप्लाई स्कीम्स डेवलप करी है, जिसके माध्यम से हम टैप वाटर सप्लाई प्रोवाइड करते हैं। तो जिन जिन एरिया में हमने वाटर टैंक सप्लाई के माध्यम से पानी दे रहे हैं, वहां पे हमने इंटीग्रेटेड लिक्विड वेस्ट मैनेजमेंट सिस्टम को भी डेवलप करा है, which integrates system management through drainage network channel, through silt chamber, through filtration chamber, and through rejuvenation of the water bodies. So this is the entire process of the integrated system of the liquid waste management system. So through this integrated system, the around 37,000 plus household is benefiting to the hygienic behavior of liquid waste management. And in terms of, if I am talking about the capacity building component, which is required for sustainability purpose, so 2,000 plus individual trained through the different technologies, which my earlier colleagues have already discussed about that technologies. ये कुछ की ऑब्जेक्टिव है हमारे इस लिक्विड वेस्ट मैनेजमेंट प्रोग्राम के, कि bring the improvement in the general quality of life of area and water conservation through safe liquid wastewater management, strengthen water sustainability in the Gram Panchayat, create support system for Jal Jeevan Mission, and capacity building and stakeholder identification and their capacity building. At a glance देखेंगे हम, अगर ये हमारा जो वाटर बॉडीज वाला इंटरवेंशन है, तो ये इसका एट अ ग्लांस डैशबोर्ड है। ये 30 लोकेशंस पे हम काम कर रहे हैं। करंटली वी हैव रिजुनेटेड 18 वाटर बॉडीज कवरिंग अप्रोक्स 45,000 स्क्वायर मीटर ग्राम पंचायत लैंड। 16 साइट्स में लिक्विड वेस्ट मैनेजमेंट का काम हम कर चुके हैं थ्रू ड्रेनेज नेटवर्क चैनल। 14 साइट्स में अभी ये वर्क इन प्रोग्रेस है, एंड इसमें 5,000 प्लस हाउस होल्ड का ग्रे वाटर थ्रू इन सिस्टम के थ्रू मैनेज हो रहा है। टोटल हमने जो कैचमेंट एरिया ट्रीट करा है थ्रू 18 पॉइंट्स, एज ऑफ नाउ वी हैव ट्रीटेड 12 हेक्टेयर प्लस कैचमेंट एरिया थ्रू दिस इंटरवेंशन ओनली। This is the entire process of this defining. If I am talking about entire process, so we are deep into the entire process. एक एंगल को हम डिफाइन करते हुए चलते हैं, चाहे वो प्री फिजिबिलिटी का कंपोनेंट हो, फिर प्री फिजिबिलिटी के बाद चाहे वो जैसे अभी तक हम बहुत देर से बात कर रहे हैं ओनरशिप और सस्टेनेबिलिटी की, तो ओनरशिप कैसे ग्राम पंचायत से आएगी, कैसे वो तहसीलदार जिस गाटा संख्या की लैंड है वो उस पे कैसे लीगली वो ग्राम पंचायत को असाइन करते हुए जीपीडीपी में ये फिर आएगा काम होने के बाद, एंड किस तरह से वो सारी चीजें डीपीआर में इनकॉर्पोरेट होंगी प्री एंड पोस्ट। तो ये पूरा ये डिटेल्ड प्रोसेस है, जिस प्रोसेस में कम्युनिटी से लेकर ग्राम पंचायत के जितने प्रतिनिधि हैं उनसे लेकर और तहसीलदार से लेकर ऑल द स्टेक होल्डर्स आर सपोज्ड टू इन्वॉल्व टू कंप्लीट ऑल द प्रोसेसेस to ensure the ownership. ये कुछ पिक्टोरियल में दिखेगा कि प्री एंड पोस्ट का कंडीशन क्या था। जैसे आप ये देख रहे होंगे डिसिल्टिंग और इन सब के बाद पोस्ट कंडीशन में ये हमारा पॉन्ड इस तरह का निकल के आया। एज पर दी असेसमेंट जहां पे जिस तरह की जगह मिलती है पॉन्ड का, उस तरह से उस पॉन्ड को अपार्ट फ्रॉम टेक्निकल वर्क की वहां का सीओडी इंक्रीज हो रहा है, बीओडी इंक्रीज हो रहा है, टीएसएस में सुधार आ रहा है, पीएच वैल्यू इंक्रीज हो रही है, हम ये भी कोशिश करते हैं कि वहां पे पॉन्ड के आसपास सराउंडिंग कुछ ब्यूटिफिकेशन का वर्क भी करें, कुछ ग्रीन एरिया डेवलप करें, बंडिंग साइट्स पे कुछ प्लांटेशन कराएं, कुछ बच्चों के लिए वहां पे लाइक झूले लगवा दें, कुछ वैसा करें कि उनका एक अटैचमेंट रहे, कि उसी बहाने वो पॉन्ड्स पे आए, कि उनके बैठने की कुछ अरेंजमेंट हो, सोलर लाइट्स हो। जैसे यहाँ पे देखिए कुछ क्रिएटिविटी है कि यहाँ पॉन्ड्स के बीच में टापू बन गया, तो ये विद इन पॉइंट्स है, तो वो लोग आ रहे हैं, शाम को बैठ रहे हैं, ओनरशिप डेवलप हो रही है, तो इससे उसकी सस्टेनेबिलिटी भी इंश्योर हो रही है कि अगर वहां पे रेगुलर बेसिस में लोग आ रहे हैं तो फिर कोई वैसा नहीं कि तालाब के किनारे बैठ के पत्ते खेल रहे हैं, काइंड ऑफ जैसा यूजली हो जाता है कि हमने डिसिल्टिंग कर दी, पॉन्ड जनरेट कर दिया, बाद में पत्ते खेल रहे हैं। और हम ये जरूर इंश्योर करते हैं कि जितने भी पॉन्ड्स पे हम काम कर रहे हैं उनमें लास्ट 3 साल में मनरेगा से काम ना हुआ हो, मनरेगा की आईडी जनरेट ना हो, सो दैट हमारा और गवर्नमेंट का दोनों का पैसा वेस्ट ना हो, रेप्लिकेट हो, लेकिन मनरेगा का काम वहां पे ना हुआ हो, वो पॉइंट पट्टे पे ना हो। तो दीज ऑल कंपोनेंट वी हैव इंश्योर्ड बिफोर इनिशिएटिंग द वर्क। ये हमारा लिक्विड वेस्ट मैनेजमेंट स्ट्रक्चर का पूरा प्रोसेस है कि किस तरह से हम ड्रेनेज नेटवर्क चैनल का असेसमेंट करते हुए, उनकी प्री फिजिबिलिटी करते हुए, किस तरह से हम ड्रेनेज नेटवर्क चैम्बर्स, फिल्ट्रेशन चैम्बर्स और कम्युनिटी सोक पिट्स के थ्रू ये पानी किस तरह से हमारा पॉन्ड्स में डिस्चार्ज होता है। तो ये उसका हम लोग ने पूरा प्रोसेस डिफाइन करा है। अपार्ट फ्रॉम दैट वी आर ऑल्सो वर्किंग इन द रूफ वाटर हार्वेस्टिंग, जिन जिन स्कूलों में इसकी रिक्वायर्ड होती है, और वो वाटर टैंक से कनेक्ट हो जाता है, विच I have tried to explain all the component through the pictorial journey. ये एक इसके बाद छोटा सा वीडियो इसमें चलेगा, जो कि ये वीडियो पूरा एक एक्सप्लेन करेगा कि किस तरह से ये ड्रेनेज नेटवर्क चैनल का पानी होते हुए सिल्ट चैम्बर और फिल्ट्रेशन चैम्बर से पॉन्ड में जा रहा है। और हमें इसी साल रिसेंट में एचसीएल फाउंडेशन को गवर्नमेंट ऑफ इंडिया जल जीवन मिशन जल शक्ति मंत्रालय की तरफ से फर्स्ट बेस्ट इंडस्ट्री इन सीएसआर कैटेगरी में नेशनल वाटर अवार्ड भी इस साल हमको मिला है। ये एक मिनिस्ट्री ऑफ जल शक्ति, ये इस वीडियो से पूरा समझाने की कोशिश करी गई है कि किस तरह से पानी सिल्ट चैम्बर, फिल्ट्रेशन चैम्बर और ये होते हुए पॉन्ड में जा रहा है। तो जस्ट टू ऐड, जितनी भी हमने वाटर बॉडीज रिजोनेट करी है, तो अपने काम को खुद बताने से अच्छा हमने जितने भी वाटर बॉडीज रिजोनेट करी और जिनको हमें रिजोनेट करे 1 साल या उससे ज्यादा का टाइम हो गया है, तो एक थर्ड पार्टी एजेंसी है, इंटरनेशनल एजेंसी है डीएनवी। तो हमने डीएनवी से अपनी वाटर बॉडीज का वाटर ऑडिट भी कराया है कि सो दैट उनका जो टेक्निकल टर्म्स, वाटर क्रेडिट्स और ये सारे होते हैं, वो थर्ड पार्टी एक ऑथेंटिक रिपोर्ट भी आता है। तो जितनी वाटर बॉडीज विजिट करी है सबका हमने वाटर ऑडिट भी करवाया है। ये कुछ पिक्टोरियल जर्नी है जो विच इन्वॉल्व्स ऑल दी कंपोनेंट स्टार्टिंग फ्रॉम civil work, community work, and all component which is being covered under the Greywater management intervention. So these are some pictorial glimpses to explain what are the process we are adopting, including all the components. So here I am summing up my presentation. Thank you.
Thank you, sir.